Hello, and welcome to this Vivado quick take on using the XDC timing constraint editor. In this quick take, we will cover how to manage timing constraints with the XDC timing constraint editor. We'll cover the editor features and see some examples of how the editor is used. Because Vivado is designed to be flexible and interactive, timing constraints can enter the design flow from different places. Let's look at a typical timing constraint setup. Typically, you start with some timing constraints in a file that you add to your project. For example, global constraints such as primary clock periods. Then, as you analyze your design interactively and refine constraints, you may enter additional constraints and timing exceptions from the Tickle command prompt. Then there is the XDC timing constraints editor. This editor is a single convenient place to manage the entire set of timing constraints. From here you can add, remove, and modify constraints. Note that the constraints reside in memory once they are applied. Once you are finished editing constraints, you can save the constraints either to the existing target constraints file or to a new constraint set. Now let's take a look at a simple example. We'll use a simplified version of the BFT example design that ships with Vivado. We'll add one XDC file, and looking inside it, it contains clock constraints for two primary clocks. We open the synthesized design, which loads the design, then applies the constraints from the XDC file to the design. If we open the timing constraints editor, we see our two clock constraints were added from the XDC file. Let's take a closer look at each of the panes. Over in the upper left is a browser with all the common XDC constraint types, with a count of existing constraints in parentheses. Each one of these represents a graphical interface where you can browse the design for appropriate objects and generate XDC commands without having to know the XDC syntax. Let's create a false path. We double-click to open the UI and search for ports, and we choose to set a false path from the input called reset. When we hit OK, the false path constraint is validated and then resides in memory. That brings us to the bottom pane, which is a list of all the constraints in memory and in the order they are applied. Our false path shows up here, and we can choose to delete it from the list. We can also add and modify constraints from the Tickle prompt. Entering the set false path command here accomplishes the same as if we were using the GUI. The false path shows up in the list of constraints. In the upper right, there is a spreadsheet style editor. Notice if we click inside any of these cells, it becomes editable, so we can modify constraints from here. Once we are satisfied with the constraint set, we can save constraints back to an XDC file. We go to the File menu, and if we choose Save Constraints, the new constraints are added to our original XDC file. You may want to leave the original file untouched, so there is another choice, Save Constraints As, which allows you to create a new constraint set. All constraints in memory are then written to this file instead. One side note, for this example we use the synthesized design for refining our constraints with the timing constraint editor, but we could have also done the same with the implemented design. The only difference is that in the case of the implemented design, once new constraints are in memory, they must be back annotated to an XDC file, and implementation needs to be rerun to process the new constraints. Sometimes when you load a design with XDC constraint files, there may be invalid constraints. This is a possibility especially when assembling a large design with pieces from many different sources, with different timing constraints. The constraints may be invalid because the target objects cannot be found in the design. In a large design with many levels of hierarchy, an XDC constraint may attempt to target a cell or a net with an incomplete or incorrect hierarchical path. Sometimes the constraints may simply have invalid syntax. In any case, invalid constraints trigger critical warnings that you must diagnose. Here's an example. The XDC file bftinvalid.xdc has an invalid set max delay constraint. When the design is loaded, Vivado warns of invalid constraints. We can check this message and determine that the start point and end point are incorrect. If you have many such warnings, it may be difficult to debug the constraint problems from the messages. The write XDC command provides an option to write all the invalid timing constraints to a file for easier analysis. The command is write xdc-constraints invalid-file name. Then I can open this file and see all the invalid constraints. So to recap, you've seen how to use the XDC timing constraints editor that manages all timing constraints in a single, organized location. This concludes the Vivado Quick Take on the XDC Timing Constraints Editor. Thank you for watching.